All right, Math 2, this is the good stuff. We're going to be factoring a trinomial when there's a leading coefficient. So there's going to be a number out front this time. So on our last lesson, we were doing the easier trinomials where there wasn't a number out front. So this is going to just add a small layer of complexity to what we're doing. The basics are still the same. We are undoing multiplication. So we're taking a trinomial and we're turning it into a multiplication problem. But having a number out front adds a little bit of a layer of difficulty to this. But let's remember where everything's coming from. So we're going to multiply this out because remember when we factor, we need to get back to this. So if I were to use the area model for this one, I would have 2x plus 5, and then I'd have x plus 1 here. So over here, this would be 2x times x, which is 2x squared. Here we have x and 5, and we get 5x. This is 1 and 2x, would give us 2x. And then 5 times 1 would give us 5 here. I do have like terms. My like terms are in the peanut right here. So my final trinomial would be 2x squared, 7x plus 5. Now, this front number, where did it come from? This front number came from multiplying this one and this one. Okay, so that's where the front number came from. 2x times x, that's how we got this 2x squared. The back number, 5, that came from multiplying the 1 and the 5. Pretty simple. Now what's tricky about this one is where are we getting this middle number from? This middle number is a combination of two different things. This would be 5 times x. Ooh, let's do a different color. 5 times x. What color? Purple. All right. 5 times x. And then these two together make 2x times 1, 2x. And then 5x plus 2x is that middle number right there. Okay, so this front number comes from these two being multiplied. The back number comes from the back two being multiplied. But this middle number comes from combining the 5 times x and the 2x times 1. This is where the complexity comes in. All right. So we are going to go ahead and use the guess and check method because it sounds horrible. We're going to guess and then check if we're right. We're not really going to guess and then check. We're going to deduce it logically, really, is what we're going to do throughout here. So let's call this the logical deduction method. What we're going to do today is we are still going to, like last time, take the 5 and then find the different factors of 5. So the factors of 5 are 1 and 5. Now, last time we'd say, okay, this is 1 and 5, so then we'd see if it added to become 7. It doesn't. So it's prime. No, it's not, because we have this leading coefficient of 2. 2 can either be 1 and 2 or, well, just 1 and 2. Okay, so what we're going to do now is we are going to start our parentheses based off of that leading 2x squared. Now, since the first number here is 2x squared, that means that I have to split it into 1x and 2x. So I'm going to put x here, that's 1x, and 2x here. Because remember, the front one and the front one are multiplying to give us this one right here. So here's x times 2x, there's 2x squared. At this point, what we need to do is, now that we know it's 1 and 5 here, because 1 times 5 is 5 for this one, what we have to remember is that we have to look at these two numbers being multiplied and these two numbers being multiplied, and those two together should give us the 7. So let's look through our options. Let's look at the wrong option first. The wrong option is to put 5 here and 1 over here. Let's see what would happen if I did that. If this were 5 and this were 2x, I would get 10x right there. And if this were 1x and this were 1, I'd get 1x right there. 10x plus 1x is 11x, not 7x. So 5 and 1 doesn't work. So instead, let's plug in 1 and 5 this direction. Well, 1 times 2x is 2x. And x times 5, these numbers on the outside, is 5x. And now 2x plus 5x, that does equal 7x. So now we know we're right. So we can see here that what we're adding is this new idea of splitting up the front number and the back number. So here's 5, 1 and 5. Here's 2, 1 and 2. And then we have to look at the combinations of the front number and the back number and the front number and the back number here to get this middle number. Because remember, that's how we're getting the 7x, by multiplying the 5 times x and the 2x times 1. It takes a little bit of practice. All right, so here we go, number 1. The first thing that I want you to do on every single problem is ask yourself if there is a GCF. Remember GCF, that's where they had a number that will go into all of them. So first thing I'm going to look at is 3, 7, 2. Is there a GCF there other than 1? No. So there's no GCF. Good. I don't want GCFs. So there's no GCF. Okay, next step. I'm going to take the 3 out front and see what kind of combinations I can get for its factors. Well, 3 can only be 1 times 3. That's nice. And on the back end, 2 can only be 1 times 2. That's also nice. Okay, so I've written down my factors, and now I'm going to focus on the front number, this 3x squared. In my 2 parentheses, I'm going to put, let's put the x here and the 3x there. Could I have done it the other way? Yeah, sure, why not? All right, so here's the x here, here's the 3x, that's where I'm getting the 3x squared. Now 1 and 2 has to go here and here. So remember, this 7x is made up of multiplying this one and this one, and this one and this one. So what if we had put a 1 here? If I put a 1 here, I would get 1 times 3x. Okay, I'm just going to write this over here. That'd be 3x. And then if I put the 2 here, it'd be x times 2, 2x. Does that work? Well, 3x plus 2x is 5x. Nope, it's not the 7x. So that does not work. Putting a 1 here and a 2 here doesn't work. So I'm going to try it the other way. I'm going to put a 2 here, and I'm going to put a 1 over here. Let's see what we get. 2 times 3x is 6x. X times 1 is 1x. 6x plus 1x, yes, that is 7x. I've got the right answer. Next one. Is there a GCF? No. Okay, that's nice. You're going to see why later on, why we want to worry about that. So no GCF, good. All right, let's look at the leading coefficient. It's 2. Oh, it's still nice. So 2, so that can be a 1 and a 2. And then on our coefficient on the last term, we've got 15. Okay, now that can be 2 different things. That can be 1 and 15, or it can be 3 and 5. So I got a little bit more decision making to do on this one. So let's start by making our two parentheses. Here's my first parenthesis. Here's my second one. Now, I need to find out what I'm going to lead off with. Well, it can only be 1 and 2, so this has to be 1x and 2x, or you can do 2x and 1x, doesn't matter. So I'm going to do x and 2x, because that makes 2x squared. Okay, now here's the tricky part. This number's negative. This number's positive. Remember what we said on the last one? If this one's positive, we're multiplying and getting a positive, but adding and getting a negative. The only way for that to happen is if both of these numbers are negative. Because remember, we're going to multiply and get a positive number, but we're going to combine these two and get a negative number. So this has to be a negative and a negative for this one. All right, now we're just going to start checking out these numbers to see if it works. What if I put a 1 here? Well, I'd have 2, and here I'd have 15, because I'd have to put the 15 over here. 2 and 15 gives me 17. That's too big. What if I put 15 here and 1 here? Well, I'd get 30 and 1. That'd be 31. Too big. So 1 and 15 doesn't work. Let's try 3 and 5. If I put a 3 here, 3 times 2 is 6. And if I put a 1 here, I get 5. What's 6 plus 5? 11. That's not enough. So let's try the other way. Let's put a 5 here and a 3 here and see what happens. So I'm going to put 5 here and 3 here. Let's see what we get. These two multiply to give me negative 10x. These two multiply to give me negative 3x. Does that give me negative 13x? Yes, it does. Negative 10x and negative 3x is negative 13x. So now we know that we are correct. All right, I'm still looking for that GCF, and I still haven't told you why I'm doing that. But that's fine. Is there a GCF? Definitely not. 5 and 48. Nothing goes into both of those. No GCF. All right, 5. Okay, that can only be 1 and 5. Not a lot of choices there. 20. Ooh, we're going to have some more choices here. Because 20 can break down as 1 and 20, 2 and 10, or 4 and 5. Ooh, I got lots of different combinations there. Okay, now this is negative, which means one of these is positive and one of them's negative. Now, unlike the last problems we did, we can't assume which one is positive and negative. We just have to say, hey, one of these is going to be a positive number, one of them is going to be a negative number. Because we're multiplying by 5, the bigger number might not be negative. It might be the smaller number that's negative because I'm multiplying by 5 over here. So we're going to split this up into our two parentheses. So this one I'm going to make x because I got 1x and 5x, and this one will be 5x. All right, now I know that one of them's positive and one of them's negative. Here's where the GCF comes into play. There's a lot of combinations. In fact, there's 6 different combinations I could do. I could do 1 and 20, or I could do 20 and 1. I could do 2 and 10, or 10 and 2. I could do 4 and 5, or 5 and 4. That's a lot of combinations. We can actually cut down on the number of combinations because there was no GCF. Now, if there was no GCF here, that means none of these have GCFs either, because GCFs just don't come out of nowhere. They're part of the factor. So we can't have a GCF down here because our original problem didn't have GCF. Why is that helpful? Because this tells me I can't put 20 here, because 20 would make a GCF of 5. And we know that there's no GCFs because we looked at the beginning of the problem. This also means I can't put 10 here, because that would give me a GCF of 5. And there were no GCFs. I also can't put 5 there, because that would give me a GCF of 5. So I only have to check 120, 210, and 4, 5. Those are the only combinations I have to check. I don't have to check any of the combinations that give me a GCF, because at the beginning of the problem, I said there wasn't one. All right, so I need to try 1 and 20, So let's just kind of write those down. 1 and 20. I need to check 2 and 10. I need to check 4 and 5. Now remember, these have to subtract to give us a negative. So one of these is going to be positive, one of them is going to be negative. So if I did 5x times 20, that would be 100x. I think you can see that's going to be way too big. And then this one would be 1x, because I'm going to do x times the 1 over here. So yeah, that's not going to work. So if this was x, and then this were, oh, I shouldn't have put it right there, but anyways, this were 5x. Okay, what if this one were x and this one over here were 5x? Well, here I would have 10 times 5, which is 50. And then over here, I've got 2 times x, which is 2. Those two subtracted do give me 48. So that's good. So I know that the 10 has to go here, and the 2 has to go here. These two give me 50x, and I'll do it up here. These two give me 2x. All right, now I haven't put in the negatives yet because I need to decide, should the 2x be negative or should the 50x be negative? Well, since this is negative 48, the 50x has to be negative. So that means this needs to be negative 10 because negative 10 times 5x would be negative 50x. And that would mean this would need to be positive 2. Oops, I don't know why I did that. Positive 2 over here. Now let's double check our answer. Negative 10 times 2, is that negative 20? Yep, it is. Is x times 5x squared? Yes, it is. Is negative 50x plus 2x negative 48x? Yes, it is. So we've got our answer there. So we look for these GCFs so that we don't have to try every single combination. All right, last problem. Is there a GCF? Yes, there is this time. The GCF is 2. Well, we better do something about that. Let's factor out the 2. So I'm going to change this into 2, and then this would be 4x squared. This would be negative 11x, and this will be positive 6. Now the nice thing here is, now that I factored out the 2, I've got smaller numbers to deal with. I don't have to deal with 8, 22, and 12. Now I've got 4, 11, and 6. That's much more doable. Now I've got a slight problem over here. 4 can be two different things. It can be 1 and 4, or it can be 2 and 2. I don't know which one it is. 6 can be two different things. It can be 1 and 6, or it can be 2 and 3. Why can't I think of words today? Now we already got rid of the GCF. There's no GCF left. Already got taken care of. Now, I've got two options for my parentheses. Now we're going to see real quick there's actually only one option. I can do x and 4x, or I can do 2x and 2x. But is there a GCF here? No. What happens when I use 1 and 6? 1 and 6, oh, there's a GCF. What happens when I use 2 and 3 over here? 2 and 3, there's a GCF. So I actually can't use these because we got rid of the GCF. There's no GCF, and any one of these is always going to make a GCF. So 2x and 2x, I don't even need to check it. I know it's got to be x and 4x. Now on top of this, I know that this is 1 and 6, so the 6 can't go here because it'd make a GCF. This is 2 and 3, 2 can't go there, it'd make a GCF. All right, let's look at these positives and negatives. I got a positive here, negative here. That means both of these are going to be negative numbers. So either the 6 goes here and the 1 goes here. Let's check that out. 6 times 4 is 24, and then I got a 1 here. That'd be 25 because 24 and 1x. That's way too big. So it can't be 6 and 1. And remember, you can't put the 6 here. So we're done checking that one. Now 2 and 3, the 2 can't go here. So the 2 would have to go here. Now let's check and see if we've got our answer. Negative 2 and 4x makes negative 8x. X and negative 3 makes negative 3x. Do both of these total to be negative 11x? Yes. Okay, actually this problem's not done. The reason why it's not done is if you multiply this back out, do you get what you started with? No, we only get this part. So we still have to leave our GCF that we took out at the beginning of the problem outside. So our final answer would be 2 times x minus 2 times 4x minus 3. And that would be our final answer because if we multiply this out, we get what we started with. Whatever you end up with, you have to be able to multiply and get what you started with. These two only give us this part. Okay, so always look for a GCF first. If you find it, factor it out. Because once you've gotten rid of it, there's certain combinations that will probably not work because they would create GCFs when you know there aren't any. All right, this is going to take a lot of practice, but I think you'll get good at it as you give it some time. All right, that's all I got, Math 2. Remember, you've got a question here. How's factoring with the leading coefficient different from factoring with x squared like we did the other day? So how are they different? Pretty big differences, right? So it's not exactly the same. It's similar. We're still doing the t-charts, but now we have a second t-chart here. So go ahead and answer that as part of your summary. That's all I got. Math hard, and I'll see you later.